Okay, when we left off in our last video, we had seen a five-number summary here. We got our five-number summary for our POTUS. Now we're going to construct a box plot. What is a box plot? It's a graphical way of illustrating what happens with our data when we are looking at that five-number summary, and we can tell a little bit about how the data is distributed using it. Now, we would determine the quartiles, the potential outliers, and adjacent values, and draw a horizontal axis where we can identify all of our values and connect them with a box. Well, I'm going to show you this here. Basically, the way it works is this. For viewing our TV times, let's say that we went through right here and we found our data box, our box plot for viewing TV viewing times. That's table 1.3 in your textbook, by the way. We ordered our data from smallest to largest. We found that the smallest was 5. Right, here's 5 right there. And that our largest piece of data was 66. Wow, look at that, 66 minutes, right? That's a potential outlier, by the way. How do we know? We'll do that in a minute. But what we do is we arrange the data and we get our quartiles. We found that our first quartile, if we arranged our data, was a little bit more than 20, right? 25 right here, 21, somewhere in there, 21. We found our median value, which was 30, right? And then our quartile 3, which was about 35 right here. Right? And what we did was in our box plot right here, we labeled our maximum and minimum TV viewing times right here. They're called adjacent values. And those adjacent values, by the way, those are values that are within 1.5 of our interquartile range, right? If we took quartile 1 minus quartile 3 minus quartile 1, quartile 3, 35 minus quartile 1, quartile 3, which is 35, minus quartile 1, which is 21, right? That is 14, right? And we multiply that by 1.5, we get a value of 14 plus 7, 21, right? So if we're more than 21 outside of that median right there, we are we're at an outlier. Of course, 66, right? That's greater than that value, greater than 21 away. Right, so that's how we know we get outliers. So now we look at our values right here. We join quartiles 1, 2, and 3 with a box right here in the center. We draw some whiskers right here on the end and a little bar right here indicating our adjacent values. And this is what our box plot looks like. Well, what does that box plot tell us specifically? Well, one of the things that it tells us is that it tells us how the data is arranged, right? Whether or not it's skewed or whether or not we've got a very big range. For example, if we did two box plots for runners versus others in a marathon, right? Here are marathon running times for our runners and marathon running times for our non-runners who decided to join, I guess weekend hobbyists, whoever runs like that. And we see that, well, of course, on average, they're low. Their time is low right here. But on the other hand, the runners, they're all a very tight little group, right? And much higher. So their times, right, is a little bit higher than that, right? So we can see how far spread out the data. That's one thing. Here's another thing, right? If we looked at these data sets, we can see when we've got data that is very regularly symmetric, like it is here in the center, right? The two boxes, our quartile ranges are pretty even. Our adjacent values to the top and the bottom are pretty evenly distributed on either side, right? If it was left skewed, the data would be gathered towards one side or the other, right? Towards the right side, towards the left side if it's right skewed, right? Right skewed means that the tail is off to the right. Left skewed means the tail is off to the left of this data set. Right? So let's look back at our POTUS data set, and I'll show you what I did. On the POTUS data set, remember that we said that our lowest score, our minimum, was 163. So I found 163 on my number line right here. A piece of graph paper is pretty handy for doing this job. 193 was our maximum. So those are our adjacent values. we found that our data set, our quartile range right here, we had 181 as the median, quartile 2. We had ours, our quartile 1, 173, right? Quartile 1. And then, of course, 184.5 is quartile 3. What does this tell us about the data? Well, there might be a slight bit of a skew. This height of 163 seems to be a pretty low value, right? Could we say it's an outlier? Well, we'd have to take our interquartile range and multiply it by 1.5 to find out. Let's see, we have 184.5. And we would subtract 173 from that. So we're going to have 111.5. That's almost 12, right? If we take that 11.5 times 1.5, right? What that means that we're going to get 11.5 plus half of that, which would be 6.75. And we would add those guys together, right? 11.5 and 6.75 is going to be 17.25, right, as our interquartile range, right? 1.5 times our interquartile range. And we see that if we were going 17.25 centimeters to the left, nope, 163 does not make an outlier right there. It's kind of a low score, and our data is relatively evenly distributed about our mean of 181 centimeters height for presence, but there it is. This is what our data set looks like. Okay, more to come.